Alright, let's look at number 8 up here. So they want to know which of these atoms would have an expanded octet. So you remember that in an expanded octet, we're talking about a central atom in a Lewis structure that has more than 8 electrons. And sometimes we see that we have too many electrons, we end up piling them on the center atom. And that can happen with pretty much any atom on the periodic table, but not with the atoms in row 1 or row 2. And remember, the reason is because these do not have 2d orbitals nearby to fill. So you have to be at least in row 3, 4, 5, or 6, because the ones in row 3 can overflow those electrons into the 3d orbitals down here. So the expanded octet ones are going to have to be somewhere in rows 3, 4, 5, and 6. So I think krypton, A, is going to be the correct answer, because fluorine, oxygen, carbon, and neon are all in row 2 and will not be able to have an expanded octet. Let's look at number 9. Number 9, they want to know what the molecular shape of this compound is, and they give us this nice hit that carbon is the central atom. So if we're ever going to figure out shape or bond angle, we need to draw the Lewis structure. So I'm going to put carbon in the middle, sulfur, fluorine, and fluorine. And we got to add up the valence electrons. So it turns out each fluorine is going to contribute 7. I don't know why my pen's not working. There we go. And then the sulfur is going to contribute 6, and the carbon is going to contribute 4 valence electrons. That'll give us a total of 24 valence electrons. We go around the outside like this, and you'll notice we've used 24. So as I said, we've used 24 at this point. Now you notice that the carbon there in the middle does not have 8 electrons, so therefore we're going to have to give it an octet by sharing. I'm looking for my eraser. And so I can pick any atom. Maybe I'll pick the sulfur and erase 2 electrons. For some reason I'm having troubles erasing 2 electrons, so we'll get rid of those 2. Well, let me step back. And we'll drop them down and make a double bond. So get rid of those 2 and drop them down and make a double bond. Alright, now the carbon has 2, 4, 6, 8. We're good to go. By the way, I'm not recommending you write an X through it like that. I'm just having a little bit of trouble with my tablet at the moment. But you get the idea. So if we're going to figure out the shape, you'll notice that there are 3 directions coming from the central atom. There's 1, 2, 3 directions, which definitely is going to make it trigonal planar. So B should turn out to be the correct answer. They said molecular shape, which we got to be careful. Remember, that's subshape, but it turns out there's no lone pairs in the central atom, so it's not like there's some sort of other subshape. So trigonal planar is the answer to 9. Let's look at number 10 here. So we want to know what situation causes the molecular shape to be the same as the electronic shape. You remember, electronic shape is the main shape, molecular shape is the subshape. So, for example, I've drawn a molecule over here where that's true. The electronic shape is tetrahedral. There are 4 directions coming from it. And the molecular shape, there really isn't a subshape, it's just tetrahedral. You remember, what would cause this thing not to be tetrahedral for its subshape is if it had a lone pair somewhere in it. So, for example, if this wasn't a bromine at the top, if it was a lone pair, then we'd think of it as trigonal pyramidal. So not having lone pairs is the hallmark where the 2 names are going to be the same. So let's see. When the number of bonded electrons is the same as the number of non-bonded electrons. I don't think that's it. When there are only non-bonded electrons, well, no, these are all bonded electrons. When there are only bonded electrons, so I think C is going to turn out to be the correct answer. When you have nothing but bonds, its main shape and subshape will be the same. So C is the answer. So which of the following numbers of electron groups, that means sort of directions coming from the central atom, can give rise to a bent molecule? Well, remember, that can happen in 2 different ways. One is you can get a bent molecule if it's trigonal planar and where you have 3 directions, and these are 120 degree bond angles. That can give you bent. But the other thing that can give you bent is if it arises from a tetrahedron, right? Where these 2 are lone pairs. There's a lone pair there, and a lone pair there. That'll give you a bent molecule 2 where these bond angles are 109.5. So there's two ways to do it. So where you have 3 electron groups, or when you have 4 electron groups, you can have a bent molecule. So the answer is E. In number 12, they want us to say what shape something would have if it has 4 single bonds and 1 lone pair. So that's 5 total directions. You remember the shape of 5 total directions is trigonal bipyramidal. One of these can be a lone pair. Say, for instance, this one is a lone pair. Remember, they always occur along the belt line. But since they're talking main shape, that doesn't really matter. It's still going to be trigonal bipyramidal. So B is the correct answer. They want to know the molecular shape, which is the subshape of this molecule. So I'm going to put the chlorines in the middle. We got to draw the Lewis structure. Bromine, 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 like that. And then we got to add up the valence electron. So what I'm getting is I get 7 valence electrons from the chlorine. I get 7 from each of the 4 bromines. And when I add that up, I get 35. Now, you know, not being an even number, the odds are something's wrong. But remember that there's a charge there. So instead of 35, we want to use 36 valence electrons. Let's put our electrons in the atom. All right, so I've put my electrons around all the bromines, and I've used 8 on each bromine. So 8 times 4 is 32. That leaves me with some electrons left. There's 33 and 34, 35 and 36. So it looks like that. And they want to know the molecular shape, which is the subshape. Now we know that there are 6 electron groups here, which means the main shape is going to be octahedral, looking like that. This guy right here, okay, where all the bond angles are 90 degrees. 2 of them are lone pairs. So we'll say the top and the bottom are lone pairs, and the rest of them, oops, I meant to do a lone pair there. And the rest of them are sort of looking like a cross. So the bond angles are still 90 degrees. And because there's four parts to it, it's going to be square. And they're flat, so it's going to be planar. Square planar.